G'day, in this video we will start to dive into the physics course. This is the first video that covers content for Module 1, which is all about kinematics. In particular, we're looking at trying to develop some skills in completing calculations in physics, and in doing so we'll also complete some revision on the concept of speed. So in this video we're going to be looking at dot point 1.1. There's no specific content statement as such. It's all about Module 1, and it sort of sets the scene for a lot of things that we'll be doing in Inquiry Question 1 in particular, which is how is the motion of an object moving in a straight line described and predicted? Hopefully, one answer to that we can all agree on is that we can describe the movement of an object using the measurement of speed. So our learning intentions of today is to review that concept of speed, which you would have looked at in junior school, and then also review, maybe even develop some new skills in being able to deconstruct, solve, and present working for a calculation style question in physics. Let's get into it. So first off, speed. Basic definition, a colloquial way of saying it is how fast something is traveling. A little bit more of a sophisticated definition, we can start using some more physicsy terms in there. Really, we could just say it's the distance traveled in a period of time. Or even more accurately, maybe the distance traveled per period of time. We'll see that speed is calculated as distance divided by time, and we measure this in meters per second. Hopefully this is all a little bit familiar to you. We're going to apply some of that knowledge right now as a practice question. Sam is driving a car down a straight, that should probably say road, at 70 kilometers per hour. She starts at 4:05 p.m. and finishes at 4:45 p.m. What we're being asked to do is calculate the distance that she traveled in meters. So when we are completing a calculation in physics, the first thing that we should always be doing is writing a data column. No matter how simple the calculation is, this is what I want to see people doing for every single question. The reason that is that I want to see people building really good habits in setting out their working. Once we get to more complicated calculations, data columns are invaluable in breaking down and understanding what is required for a question. So while a data column, when I show you what that looks like in a second, may seem a little bit simplistic, redundant, and a waste of time, it will save you time in the long run. The better you are at it early, the more effective you're going to be at using it when things get really complicated later on in the course. So first off, I'm going to draw up that data column. Now what we draw up in a data column is all of the key information, the key numerical information that we find in the question. We also want to identify in the data column what we actually have to calculate or find. And I like to identify this first. Now we're being asked to calculate the distance traveled in meters. So that's what I'm going to write down first, is that distance is unknown. That's something that we want to try and find. The next piece of information that I want to be able to put in is known values. So 70 kilometers per hour, this is a measurement of speed. Notice that I'm also putting in the unit of measurement here. Units of measurement will be really important. And the other thing that we need to put in is this information here about the time. Now we can do a little quick calculation right now if we choose to. We have 40 minutes. That is the time that Sam was traveling in the car. But now we have all of the data. That means that we can move to the next component of the question. The next thing that we need to do once we have a data column is select an equation. Now mathematical equations are used to solve for unknown values, and they're usually found in the data sheet. When we're trying to pick an equation, what we need to do is select an equation where there is data for all of the variables except for the one that we want to be able to calculate. As we start to do more problem solving and calculations in this course, that statement might make a little bit more sense. Maybe you can come and review this concept a little bit later. But we already know what equation we're going to be using for this calculation. In particular, it was written before. I did tell you that there was a relationship between speed, distance, and time. In this case, according to our data column, we have speed, we have time, based on the little calculation that we did, but what we don't know is the distance. So in this case, we have an equation where the values of all variables are known, except for the solution, the thing that we're trying to find. So we know speed, we know time, we don't know distance. So this is going to be a useful equation to use. Next thing that we need to consider is our units of measurement. Now, our units of measurement must match for all terms in the equation. Now, conversions can be done in the data column. They can also be done as adjustments in the final answer. Now we should be able to see here that the units for time do not match. We have minutes and hours. So what I'm going to do now is choose to do a conversion before I start calculating to make sure that there are no errors in the calculation. The way that I'm going to do that is convert my time into hours. Now to do that, I'm just going to divide by 60. And that is equal to 0.66 hours. Notice too that in a moment when we do our calculation, our distance is going to end up being in kilometers. I'll do that part of the conversion at the end. Another thing to do when completing calculations in physics is to solve the equation, then substitute. Now equations should be solved for the unknown before substituting them. Again, when we start working with really complicated equations or multi-step calculations, this is actually going to be reducing your workload, the amount of writing that you need to do, and also can reduce the chances for error because it can be really easy to miswrite or misenter numbers. So the less numbers that you write and enter into your calculator, usually the better. This may be a little bit different to ways that you've completed calculations before. I encourage you to practice at the beginning because again, the more practice that you do at the start, the more straightforward it's going to be when you really need to rely on skills like solve and substitute. So far, this is all the information that's the most important we have. So what are we doing is solving my equation first, then substituting in. So to solve for our distance value here, we need to make sure that in our equation, distance is what we call the subject, meaning that it's alone and by itself on one side of the equation. What I'm going to do first is move the thing that's on the same side as distance, and that is time. To be able to move time away, I need to be able to multiply by time on both sides. This should be pretty familiar to solving algebraic equations, something that you've probably been doing since year 7 or year 8, which means that speed times time is equal to our unknown distance. At this point is where we then substitute. So we can put in our speed, we can put in our time, and when we put that into our calculator, we should get an answer like this, 46.2. Now the units of measurement here is still in kilometers, and that's because we substituted in a speed in kilometers per hour. Note, this is where I'm going to need to do the next conversion because we need to be giving a final answer in meters. To figure out what the answer is in meters, we just need to multiply that number by 1,000. Answer is 46,200 meters. So just to quickly recap, when completing calculations in physics, some things that you really want to be mindful of as you're doing it is to make sure that you put down a data column to extract all the key information out of the question so that we can make a plan of attack. That plan of attack usually involves selecting an equation or a set of equations that you can use to then make a calculation, remembering that you want values for all of the parts of the equation except for the one that's unknown. We then need to make sure that our units of measurement are working. Maybe there's some conversions that we do in the data column. Maybe we need to be mindful that there's a conversion that might need to happen at the very end of the calculation. We then need to solve our equation for the unknown, substitute our values in, get our final answer, and double check at the end that our units of measurement match. And there you go, some key skills to complete a calculation in physics. Again, these skills may seem cumbersome, they may take a little bit of extra time, they may be frustrating, but if we find some mastery in these skills to begin with, it's going to mean that when we get to some more complicated calculations later, they again are going to make a lot more sense. Now in the next video, we're going to start looking at some key concepts, which are mechanics, kinematics, and dynamics. These 3 words underpin all of the things that we'll be unpacking in Module 1 as well as Module 2. So I'll see you in the next video.